Okay, we're going to do one last waveform. This is number 5, characterized by 2 non-zero half cycles. This is the graph to which we refer. We've developed these equations in a previous lecture. This is going to be a little bit difficult since we do have 2 non-zero half cycles, and not only that, the second v at t expression is a binomial, so that will complicate our calculations a bit. The waveform is even, which means we will not have any sine terms, so we can skip the bn calculation. Let's begin with the calculation of a0. Here's the formula. We're going to have to split the integral into 2. Okay, so notice the limits here are for the first half cycle, and the limits here are for the second half cycle. So we've got the first v at t, the second v at t substituted. In this step, I've gone ahead and integrated each term. So here we are integrating t. We get 1/2 t squared. The constant remains in front. Exactly the same thing here. The integral of t is 1/2 t squared. Its constant is still in front. What is the integral of this constant? It is 2v max times t. When you integrate the constant with respect to time, we get 2v max times t. In the next step, I'm just going to simplify that constant and this constant. In particular, we're going to be doing this, canceling out these 2's, and it looks like that. So what remains? Substitution of upper limit and lower limit. Same thing here. Substitution of upper limit, subtraction, substitution of lower limit. So here's what that will look like. Okay, so right here we get t squared over 4 minus 0, upper limit minus lower limit. This is a binomial, so first capital T is substituted here, and that's shown within this bracket. Subtraction, now the lower limit of capital T over 2 is substituted here and here inside of this bracket. This now becomes v max over 4 times t. Here I canceled like this to give me v max over t. And lastly, within this last bracket, 1t can be canceled here and here. Also 2 can be canceled here and here. And that gives us this term and this term. Okay, take a look inside this term. We have -1 v max t plus 2 v max t. Overall then, that is 1 v max t. This is -1/4 v max t plus 1 v max t. So it is +3/4 v max t. Okay, so here is the first term. The bracket became this. The second bracket became this. So we take a look at this. How many v max t terms do we have? 1/4 plus 1/2 minus 3/4. So in fact, we have 1/2 in here of v max t. We might want to first cancel out the period from the calculation. Maybe that makes it look even better. You see, like this. So that means we would just have 1/4 Vmax plus 1 Vmax minus 3/4 Vmax. So 1 plus 1/4 minus 3/4 is 1/2. So the result is Vmax over 2. Okay, so that was the calculation of A0. Now let's have a look at the AN calculation. Now this is long. Okay, so here's the formula first of all. Now we have to break it into 2 because we have 2 different half cycles, neither of which is 0. Therefore, we substitute our 2 different V at t equations, and it will look like that. Okay, so here's the first V at t, the second V at t, and notice what our limits are. Okay, now from there, I have actually made 3 integrals out of this. And I did that by opening up the bracket here. Okay? So here is the first thing that we are integrating. I pushed its constant out front. So its constant is 4 Vmax over t squared. Here it is. And the integral includes t and the cosine term. Then this will form the second integral right here. You see we'll have a t and the cosine term to integrate. As for the constant, I took negative 2 Vmax over t and multiplied it by 2 over t to get the correct constant in front of that second integral. And the third one, which didn't fit on the same line, the third one is here. It was formed by doing this, taking this and multiplying it by this. I also applied this constant. So the constant on the cosine term, see, just a cosine term now. The constant was the 2 Vmax times 2 over t. So here it is. Okay, so essentially, we split this and we applied this constant here, 1, here, 2, here, 3. And we got this result. Now, each of these things is on our formula sheet. This one right here with the t, this one right here with the t, and this one without the t in front. They are all on our formula sheet. So we're using this one twice and this one once. So you can see why it's going to get very large. Okay, so this constant is here. This integral is removed and replaced with all of this, keeping the limits the same. Now here, minus, okay? This constant is in the front. This integral is removed and replaced with all of this. Notice the limits are the same. Plus, so plus sign. Now we're on to this last one. The constant is here. The integral is replaced with this. Okay, so in that step, I used the formula 3 times. Once for this integral, once for this integral, and once for this integral. So the formula sheet was used 3 times. Following that, I just simplified the constants. So I simplified this constant here. It became Vmax over n pi squared. I simplified this constant in the very same way. It is Vmax over n pi squared. Lastly, I simplified this constant. It is 2 Vmax over n pi. So this is what we have now. And as you can imagine, it is time to now substitute upper limit minus lower limit here upper limit minus lower limit here, and upper limit minus lower limit here. So let's go on to do that. I know, don't look ahead, it just gets scary looking. That's why I keep covering it, to try to keep everybody calm. Okay, so where were we? Yeah, we were just here. Okay, this is the stuff that we just got up to right here, see? So all I'm gonna do is show you. Inside this bracket, first we put capital T over 2, here, here, and here. And in doing so, we get this. Cosine n pi plus n pi sine n pi, okay, minus, then you substitute 0 here, here, and here. Cos 0 plus 0. Okay, we're here, minus, there it is. Constant in front. And then substitute capital T here, here, and here. You will get this, cosine 2 pi n plus 2 pi n sine 2 pi n. Minus, then you take your lower limit and substitute it here, here, and here. Cosine n pi plus n pi sine n pi. Plus constant, so plus constant. Now in here, it's just a single term, not a binomial. First we substitute capital T, we get sine 2 pi n, subtraction. Then we substitute capital T over 2, we get sine n pi. Okay, so that was evaluating by doing upper limit minus lower limit. Now we go back and calculate what we can. The sine of n pi is always 0. The cosine of 0 is 1. Now, the 2 in here makes this an even number of pi's no matter what n value is substituted, right? If we put a 1 here, we get 2 pi. If we put a 2 here, we get 4 pi, and so on. We're going to get an even number of pi's because of that 2. So this value is always 1. The sign of an integer number of pi's is always 0. Down here, same thing. Here, same thing, same thing. So we got a whole bunch of zeros. So what's left? This term is left, minus 1 in here. Inside here, what have we got? We've got 1 minus this term. And that's it. Okay, so again, inside here, just cosine n pi minus 1. Okay, then minus this constant, and inside here, 1 minus cosine n pi is there. All right, now cosine n pi sometimes is 1, sometimes is negative 1. When is it equal to 1? Cosine n pi is 1 when n is even. Cosine of 2 pi, cosine of 4 pi, and so on. What happens if we put 1s here? Then we get 0. So we can say when n is even, the cosine of n pi is 1, which means we would have a 1 here and a 1 here. And therefore, an, which we've been calculating, will be 0 when n is even. So there will be no cosine terms when n is even. What happens when n is odd? Well, when n is odd, these quantities will be equal to negative 1. So when n is odd, then we're going to be substituting negative 1 here and here, which means that in here you'll get a negative 2, and in here you'll get a positive 2. Okay, so an would be this times negative 2 minus this times positive 2. In other words, we will get this as our coefficient, negative 4v max over n pi squared. That's when n is odd, remember? So then I substituted some odd numbers. I substituted 1, 3, 5, and 7. So of course that means here, 1, 3, 5, and 7. So you would get the following coefficients. And then at this point, you could write out your Fourier series. So we have an A0 value. We don't have any of these sine terms. So we have this. And then we have these, the odd ones only though. So we'll have this one and this one, every other one. So we don't have the ones with even numbers for their subscripts. Okay, so when we do A1, the angle will be 2 pi over capital T. When we do A3, 6 pi over capital T times little t. When we do A5, then it will be 10 pi over capital T times little t, and so on. So here is the result. That's the A0 term. Here's A1, and look at the angle, it's 2 pi ft. Here's A3, 6 pi ft for the angle. Here's A5, 10 pi ft for the angle. Here's A7, 14 pi ft for the angle. From these coefficients, I common factored. I didn't touch A0, it's still out front. From the coefficients, I factored negative 4 v max over pi. You can see that that's going to leave you with a 1/9, 1/25, and 1/49 in front of those terms. I ran out of room, so I actually only showed 3 cosine terms in my final answer, plus the A0 term. Wow, that was a marathon for sure. Okay, I hope you understood how we arrived at this Fourier series. And now you have 4 examples in total. Remember that I did with you now waveforms 1, 7, 9, and 5. And you have videos for all of those calculations. And they should help you greatly when you're doing your assignment for this unit. Okay guys, take care. Bye-bye.